Actually, I could get it even smaller though. Never mind. Um, yeah. So by the way, guys, so far I just took out the four screws on the back of this MG996r high torque metal gear servo motor. Took out the four screws, removed the back, just like that. That's how it was. I didn't change anything. You can see that you've got okay. As you look at it here, you've got your three wires that run to your potentiometer, which is back in here and comes out the top here. I've taken the whole gear train off the top, so that's why it's shorter now. You can see it's like a stubby one. It was like up to here, so I cut it in half already. You can see with this on, it's this tall. That off and all the gears off, which I laid out here. It's much shorter now in profile. Really, the idea unit circuit board, which is here, I want to maintain that and extract the DC motor and use it for continuous rotation by doing the 2 resistor mod to remove the potentiometer, which then I can reuse for other things. And basically just keeping the servo motor as a DC motor for my muscle pulling purposes. By just keeping the circuit board and the motor, I feel I can mount the circuit board sideways next to the motor, like right here, and then we just got the motor like that, and something that small can actually fit like in the palm, in the wrist, whatever, but this whole unit together would be too big to fit like anywhere through here. I'm basically wanting to reduce its overall size and volume while retaining its functionality by removing the plastic covering and removing the control circuitry and just using the motor and the control circuitry without the use of the potentiometer, because I want a continuous rotation anyways, and basically just decreasing its form factor so we can fit more of them in a smaller volume area of the robot's arm and body. So by doing that, we're able to have way more motors in the arm, in the hand, etc., and gain way more power, because I'll run out of room otherwise. So I've got to be able to get these out of the plastic casing and use them isolated and alone. My next challenge is I would like to remove the motor from the casing. So what I'm going to do is just cut apart the casing. Well, this casing's super strong though. Wow. I mean, that is strong casing. Wow. Melting this down to make for some great strong plastic to use for like making custom gears or any type of parts, because this plastic is super hard. It's a very well made motor. So I want to pull out this motor from this black part, and I'm not sure how I'm going to do that yet. Okay, I'm going to try just tugging on it with pliers. See if that works. I don't want to break it though, but if it's just a matter of pulling on it. Oh, see, there we go. That's all I had to do. Okay, I'm glad I did that. It was just a matter of pulling on the motor, that's it. And then, as far as the potentiometer, that'll be easy now. I can actually cut. Oh, this is going a lot better than I thought it would. Okay, so these Oh, this is excellent, man. I didn't even have to damage anything. Uh, yeah, I'm just going to cut these 3 wires for the potentiometer right here. Okay, that didn't work. I need some good electronic side cutters. Okay, and there we go. We have officially extracted the control unit and the DC motor. That's what I wanted. That's excellent. So you can see how small this is now. And what I can do is mount the control unit, something like that, and then swing these down, maybe. And then boom, we got all the power of the motor, and it's like you can see that if you try to install this in the arm, that's going to be a lot easier to fit in the arm than in its original state, which is like this. That's huge. So we just took out the controls and the motor itself and got rid of all this extra weight and unnecessary fluff. We just took the essence of the motor out. So we can fit way more of these into our robot than we could fit these. That's obvious, right? It makes sense. So for every one motor I could fit like 4 of these because, well, no. Well, yeah, because you got to consider this blade extending out as well. That's like an extra inch, so you could figure like one. If we laid them like this, we could probably do 1, 2, 3, 4. Yeah, so like 4 of these. So we're basically fitting 4 motors for the price of 1 in terms of the volume it's taking up. How powerful is this motor? This is a MG996r motor. It's 800 milliamps, 6 volts. Its stall torque is about 12 pound-inches. So at 1 inch away from this center axle, at a 1 inch arm distance, it could lift 12 pound weight. So if I had a 12 pound weight and that were attached to a 1 inch arm, it could lift that, or that's where it'd stall out at. So the closer you attach it to the axis of the output shaft, the more torque it'll have, but the less speed, because it's going to be turning really close, making little windings. And that's okay. So basically that's my concept for this motor. In fact, I'm going to have this thing as a little pulley just winding the string. So now I have to mod these 3 wires with what's called the resistor mod, where you connect 3 resistors and then 2 resistors that simulate a 90-degree angle of the potentiometer, so that the servo always thinks it's at 90 degrees and it will continue rotating at full speed. If you tell it to go to full turn or 0 turn, it will keep rotating because it won't ever feel that it's arriving where you told it to. And that's what I want. I'm going to tell it to stop rotating with the Arduino once the arm itself has moved to where I want it to move. or the finger or whatever has moved to where I want it to, then it's going to stop. It's going to tell it, okay, stop. And in order to do that, I think it will just tell it to go to 90 degrees, which is where this thing always thinks it's at anyways. You could also extend the wiring from the circuit board to the motor, so you could mount the board on the torso, saving more space in the arm. Absolutely. So yeah, that's a great point. Basically, just by extending these two wires that lead to the motor, you can put this circuit board wherever you want. Since it's a flat circuit board, well, it should be pretty flat. You could mount it anywhere. It won't take up any space or weight. I mean, it's a really flat board. You can see the way the wires are mounted onto it, they're kind of sticking out, but I could resolder them to be a lot flatter. They're basically soldered on to be vertical. I could resolder them like to be completely flat. In fact, I think I could just stretch them to make them flat just by bending their orientation. There we go. And then this is actually a lot better. Just stretching it all out, and now it's flat. So I can actually put a motor on top of here. I'll probably have to like heat shrink the whole board to make it completely hidden, so that no other random wiring could cause a short or water get on it or something. It probably should be like, you know, isolated to protect it. But besides that, this is good to go. Like, this is flat form factor, as flat as you can get, just a little motor off the top. And I've got big plans for how I'm going to rig this to be a pulley to pull on the muscles. I'm excited. This is a big breakthrough. I didn't think it would work that well. I didn't have to make any cuts except for the potentiometer wires, which I could have desoldered. I didn't have to break anything or whatever. I was able to completely disassemble this motor and get out this. And that's the heart of it. That's the brains, that's the brawn. The rest is just gearing. Gearing and control. And I'm going to have all the control done completely separate through the Arduino. So this is huge, guys. Huge. Yeah, this is a successful breakdown. And I really can't be happier with how quick and easy that was. And if I wanted to, I could actually rebuild the motor completely from the components, so I'm not going to throw anything away. And those three wires are the potentiometer wires that you have to hijack with the resistors later to make the board think that it's always at 90 degrees. So what this does, this is the motor, and that's the geared output shaft. We put a tapering extension on the output shaft with two flanges on it and a support bar. And the support bar keeps it from wobbling and gives it additional stability in order to protect the motor. And then it can't really move left or right that way. And then we got string that wraps up as it turns, pulling this way and this way. So this string would loosen as it turns clockwise, and at the same time this string would draw tighter as it turns clockwise. So these would be opposing muscles, and this string would be running through this tubing in order to make it able to go anywhere I want it. So that's how to actuate the servo into a pulley type of system. question would be, would it turn too fast for me? And I would say no, because the size of this output shaft is going to be like, really like, just like a pin or a toothpick. And that means it's going to take many, many, many revolutions for it to wind up this string. It's going to be like boom, 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 winding the string very quickly in tiny little windings. And it will need all the speed this motor is producing in order to wind the string fast enough. And then plus, you can control the speed. Well, I mean, like at its peak speed, the muscle needs to move at its peak speed. And I might need the muscle to pull like a full inch, which would take like 50 revolutions for an inch. And that inch needs to be pulled in like 0.5 seconds. So let's see, 50 revolutions in 0.5 seconds. What's the RPM on that? Well, that'd be 100 revolutions per second for 60 seconds. That'd be 6,000 RPM. And I believe this motor probably is 6,000 RPM. That's going to be perfect. Let me just look up DC motor in general. We'll look up a small one just to get an idea of what DC motor RPMs are in general. And actually, I'll do 6 volt. So that's hobby level. Okay. Micro super speed, blah blah blah. Yeah, that's probably what's used in this type of motor. Okay. Supposing it's something like that. 16,000 RPM. But under load, it's going to be a lot less. Let's say a fifth of that, which would be about 6,000. So yeah, under load, it's going to be a lot slower. And yeah, I think it's going to be spot on, guys. This is going to work great. I want to try to extract now the potentiometer out of here, which I would like to be able to use I'm going to put pressure and then open up both tabs. It worked. There we go. That is the potentiometer that came with the servo. Okay. And I can use that, you know, mount it somewhere in the bot to monitor rotations and stuff. As a potentiometer output shaft turns, its resistance changes, and so by sending in a 5-volt feed from the Arduino and then a ground from the Arduino and then measuring the inner part of the potentiometer with your analog input pin of the Arduino, you can determine how much it has turned. And so by attaching it to various joints of the arm, the Arduino will know whether it's closed or open or halfway. It can measure the degree of movement of the different joints. So these potentiometers I'll be able to use. So essentially the only thing I'm not using are the metal gears. because I don't think I need them